Hi, welcome to the very last 5th grade module overview. My name's Debbie Thompson with the Elementary Math Department, and with me I have
Baxter Schmidt. I'm a 5th grade teacher at Riverside.
So we kind of mixed things up just a little bit for this last video for you guys. What I want to go ahead and do really quick is make sure right now, if you do not have your progressions notebook with you and you do not have the module 5, you need to stop this video and go grab them really quick. So go ahead and do that really fast. So now that you have your progression notebook, and remember, if you don't have your progression notebook, you can get these online. I found the easiest way is just get on Google, just type in math learning progressions. It's really easy. Click on it. It's going to be the first thing. It's a little misleading. It's the University of Arizona. Those of you that have been there, you're pretty familiar with that. Click on that University of Arizona site, and they're all on there. And so you will need 2 for this particular module, because you want to make sure that you have both the measurement one and the geometry one. And I know sometimes the measurement one is a little misleading, because when you look at it, it says geometric measurement, but that is your measurement progression, and then make sure you have your geometry progression. So I'm going to go ahead and look at the measurement progression first, have you guys look at it. If you have not already read the 5th grade portion of your geometric measurement progression, it starts on page 26. You will want to look from page 26, and mostly you're really looking at the volume piece. The very beginning talks about conversion, but you don't need to worry about that one so much as you do about the volume. In here they really talk about solid units being packed with cubes, and then liquids are filling it, and we're going to talk more about that later when we get to that particular topic, but I want to make sure that you see that it is in the learning progression, so it is an expectation that you get the kids to understand that distinction between the two. You really need to make sure they understand about unit cube. I think a lot of kids, since they're used to unit fraction, unit cube is pretty easy for them to be able to remember. Really getting into understanding about the decomposition and composition that goes with understanding about volume. They're really going to get into the layering aspect about volume. And then you want to make sure the kids really have a kind of an understanding about the solid figures too, the 3D shapes. We're going to talk a little bit about those pieces and parts and some of the terminology, because that was one thing Baxter and I were talking about, is that there's a lot of vocabulary, a lot of terminology that you need to really know well as making sure your kids do. You also want to make sure that they have, if you look on page 27, down towards the bottom of page 27 on the progression, talks about that volume, recognizing that volume is additive, and we'll talk about that when they get into the whole layering piece. They can start seeing the additive portion. So those are kind of just the big highlights of that progression. Now I want you to go ahead and look at your geometry progression really quick, and grade 5 starts on page 17. I don't think they've really done much with geometry before now, right? If I remember right. Nope. So this is really your first go into the land of geometry. So you really want to make sure you go through and understand about, again, they're getting into that whole decomposition and composition of shapes. This is building a lot of what they've done in 2nd, 3rd, and 4th grades. The only thing is that since this is really the first time that we've really gone full all the way through the engagement in Y, there could be some holes or some gaps that some of the kids might have. So we're going to give you some hints and tips as we talk about those particular topics. So, but want to make sure that you read through all of that. I do want to point out that on page 18 they have a Venn diagram showing the classification of quadrilaterals. It's a great Venn diagram. It's just that they are missing the component about kites. That is a subcategory that the kids we're supposed to start knowing about kites back in 3rd grade. So we're going to kind of share with you some of another Venn diagram that you might find useful. And there's also one in the Engage NY curriculum that you might find useful. But I did want to point that out, that that's probably something that's going to get fixed. And in fact, I know the geometry progression for 7 through 12 just came out last week. So especially if you're a 5th grade teacher, you want to look at 6th, 7th, 8th grade, kind of see what's coming up. You might want to go ahead and get that and see it too. So, okay, is there anything I've kind of forgotten about? Progressions?
I don't think so.
That's about it. So, the next thing you want to make sure you have is you want to have your module overview. So make sure you have your module with you. And yes, this will be your last notebook that you're going to have to pull out, so you can kind of do a little celebration for that. In your module overview, they go through and they give a lot of information about topics A, B, C, and D. It has the 4 topics for this one. As I was going through and I was reading these topics, and I was talking with Lynette and Baxter about the sequencing, because after having read that progression, when you were going through and hopefully you stopped and you paused so you could read that progression piece, that you will have noticed that they really talked about how volume comes in after they have a really deep understanding about shapes and then a deep understanding about area. So when you look at the kind of the flow of the topics, topic A and topic B gets right into volume, and then C is area, and then D is the classification and analysis of the 2D shapes. So Lynette and I started talking, and then when Baxter got here, we were talking with him. And I know the 5th grade team will kind of probably be talking about this some more as to what we want to do for next year on the sequence guide. But what we're going to say is for this year, if you would like, it just depends on your kids and how it will flow for you. I would probably start with topic D first, then I would do C, because I wanted to start with 2D shapes, making sure they understand all that. Then I would get into area, which is topic C, because they really need to build that understanding, make sure they have the understanding of area. They did area in 3rd grade and 4th grade, but they really haven't done area. I mean, you've done the area model in multiplication, but you haven't really used it as just area. So kind of make sure you hit that.
And it will be a nice transition from Module 4, finishing up the last half of Module 4 being multiplying fractions, leading into finding the area of rectangular figures with the fractional side lengths would be a smooth transition with a short break in between.
Yeah.
Before you hop into volume.
And yeah, I'm glad you said that, because I almost forgot about that, because it is area with fractional side lengths, so it's not just whole numbers. Then after they're done with that, then you want them to then be able to take that understanding about area and understand, now I can go to 3D. I can start thinking about what does that mean when I want to do volume, because they need to have that understanding about what the base is, which is the area. We'll be talking more about that as we go on. There's a lot of stuff we got to take. So, but that's just something to think about. If you wanted to start topic A, B, C, D, that's fine. I don't think there's one way is necessarily going to affect your kids a whole lot more than the other. It's just depending upon thinking about your kids, thinking about how you need to build those geometric ideas. You know best how your kids learn and what they need. So we're kind of leaving it up to you. But we will go through and go through the topics as they are here. So if you want to switch it up, then you just do it differently. The other thing I just wanted to say really quick, because we are going to hit terminology pretty heavy as we go through each topic, but I did want to make sure that you guys understood that the terminology, the vocabulary that is required for all of these topics is quite extensive. And as Baxter and I were going through and we were talking about a lot of these things, there are some things that we want to make sure you're very, very clear on so that you can be clear with your students. And there are some things that we just need you to know so that you can maybe avoid, if a kid says something, you can kind of get rid of those misconceptions for them up front before it gets too far. So I don't think I left anything else. So now we're going to start right off with topic A.
All right, so topic A, as it says, concepts of volume. The two focus standards that we'll be looking at is 5MD3, and that is the volume is made up of cubic units, and 5MD4, which is measuring the volume by counting. And so right into lesson 1, we start out with focusing on the bottom layer and the 4 cubic units and talking about what is the cubic unit. Can we shift that around, and is the number of cubic units changing? I will say that on page 5A6 in your lessons, on the notes on multiple means of engagement, it talks about students with the spatial reasoning difficulties, and that's kind of once you get into the isometric dot paper, that can be very challenging with your students if they have the spatial reasoning difficulties, and seeing and repeating the process to be able to build it horizontally, build a prism horizontally or vertically. Either tracing rhombuses on a piece of isometric dot paper, or we had talked a little bit about on the illuminations. There are some different activities that students or teachers can get on there with their kids, and it's a little bit easier, not as demanding to be drawing the cubes, but you want to go ahead and show that?
I'll show this really quick. And this is the illuminations.nctm.org. I think most everyone's pretty familiar with this site. It has some great interactives, but the thing is once you go to illuminations.nctm.org, then you'll want to click on where it says up at the top. It'll say Lessons, Interactives. You want to click on Interactives. Then once you click on Interactives, then over on the right hand side you're going to see kind of a navigation panel. You need to go ahead and click the box next to Interactive. So there'll be a little check box or a little check mark in that box. Then right underneath it, because you're trying to restrict it to just interactives, then when you go to the search, the site box right underneath it, you want to put in volume. And when you put volume in, you will get those the 2 apps that we were that Baxter was just referring to. The one was the isometric dot paper, where you the kids get to click on each of the different rhombuses that they can then create the cubes. But then they also have a cubes app where it's a net basically of the various shapes, and then they can fill them, and then they can pull the nets up to actually then enclose it.
And on the isometric dot paper, the drawing activity in lesson 1, we talked some about how drawing that is not a specific standard, and there might be some students that are not ready for that specific activity. So be careful about what students are moving on to that activity, as well as what they are being asked to do in their problem set. The focus of that lesson is just what is a cubic unit, and starting to talk about volume and that it is a 3-dimensional object. So lesson 2, moving on. As students are packing and they are filling the nets, we talked about how this is a good time to, again, terminology and vocab is very important in this unit, but be referencing, are they seeing the different dimensions, and start to talk about that could be the length, that is the width, and so on. Not getting into formulas yet, that will come later, but we are just making observations and talking about what they are seeing there. And I forgot to mention, and I will probably reference this throughout several lessons, but there are a lot of pictures that they say project on the board or draw on the board, and I would highly suggest even just the snipping tool, going online, going to the lesson, using the snipping tool and copy and pasting that into a smartboard lesson or a PowerPoint. Saves a lot of time for the teacher and will keep the students more engaged because of a quicker pace. And then going from there, if you just have even a blank picture, if that's what they want you to project, you're able to label and have the further discussions without taking the time and hopefully drawing it right the first try. So, let's see. Also on that lesson 2, there were several activities. For example, on number 2, where they have the prisms, certain students could probably benefit most from labeling the prisms, whether it's with the length, width, or height, or on number 3, where they have the net, constructing the net, and again packing into that to continue to talk about the different dimensions that can then fit into the cube. But just, we were talking about, we need to be selective in what our students are being asked to do, and knowing that in their 10 to 12 minute time period for the problem set, it's not always likely that they are going to complete every single thing that is there for them. Lesson 3, that's where we get into strategizing, and that's very important in counting the cubes in a prism. A lot of students can count one by one, and we want to get away from counting one by one, but maybe counting one layer, and how can we strategize to find the total volume there. And if we stick to strategizing, then that is a good way to lead students, maybe potentially into generalizing a formula, but we aren't hopping straight into base times height or length times width times height, trying to give the students more meaning by letting them count and strategize and make those different observations. On problems 1A and 1B in that lesson 3 problem set, I just had a note about encouraging discussion for what is a layer, and if we have multiple layers, how can we count that? How can we add them together to eventually find the total number of cubes rather than counting one by one each time? Did you want to show that?
We were going to, Lynette and I were able to find these clear boxes. It's kind of hard to see the clear box, but it really makes it kind of nice, because then the kids, those that at the beginning, maybe, I don't know, it would be lesson 1, lesson 2, if they need to start thinking about counting the blocks, they can actually put it on there. But eventually, of course, you don't want them to count the blocks. You want them to be able to see those, just like what Baxter was saying, you're having your dimensions, and then being able to see those dimensions. We just really thought it was kind of nice. I know it makes it nice because then the kids can actually see how it's filled. I know back in the old days when I first started doing this, I would get my cubes, but I had to get like tissue boxes, shoe boxes. I know they were talking about mint boxes. Is that what it was?
Yeah, there were several suggestions
in the lessons, but they're not clear. But I know nowadays you can go to even Walmart, Target. I think they have these gift boxes. We were able to get these from a floral place that were relatively inexpensive. You do want to make sure, though, that you're trying to buy the boxes, if you're going to get the clear ones, that are able to use. They're either in by inch or by centimeters, so that your tools that you're packing them with fit well for the kids and they don't get frustrated. Now, as they get better at it, though, then I think you could have the odd sized, then the kids can go through and start figuring out, oh, I can't fit a whole cube in here, but how much of this cube can I fit in? And then you start having those discussions with the fractional pieces, but that is not necessarily expected for this particular one, unless you have kids that are just really doing quite well, and you can kind of throw, especially those kids that are at those higher levels, and you can kind of throw some of those things that make them really think a little bit more deeply. But we really just like these rectangular, or I mean these, the rectangular prisms, but they have all kinds of different sizes, different shapes. It really gets the kids to start thinking about the layers that Baxter was talking about. So I can see this has only 2 layers, this has 3 layers, but then how many blocks are in how many unit to cubes are in each layer, that kind of thing. It really helps them start building that understanding about the formula before they actually do the formula, because then they really understand what they mean. So,
all right, I think we're ready to move on to topic B. And so this is volume and operations of multiplication and addition. The 2 focus standards are 1, again, 5MD3, where we're talking about how volume is made up of cubic units, as well as 5MD5, and that is relating volume to addition and multiplication. Just a general note on topic B, that it's focusing on multiplicative, right? Reasoning, which students will rely on their systematic counting methods that hopefully they were starting to not formulate, but create a system for by counting in lessons 2 and 3, and that will be required in topic A. So lesson 4, I thought this was a nice transition from counting layers in lesson 3 to moving into the multiplying and starting to lead into generalizing the formula. It also references several times in the lesson the word face, and that is another reason why we don't want to teach base times height yet, because if we focus a lot on base rather than layers, talking about the face and base is going to get very confusing. Do you want to explain that real quick? I won't try.
It is so crazy. We were talking about how Lynette and I mean, when we first started doing this job, however years ago, base and face, that was one of the things we were having a lot of discussions about, because we want to make sure that we understand what it is, that when we talk to teachers, we can give you guys a clear understanding so that you make sure you don't have any misconceptions for your kids. And I could not find my triangular prism. So, but I do have this rectangular prism, and as you know, a cube is also a rectangular prism. It's just a very special rectangular prism, and it's a cube because all the faces are squares. But in a rectangular prism, the thing that we want to make sure that the kids kind of understand is the difference between the base and a face. And we finally came up with all bases are faces, but all faces are not necessarily bases. So just think about that for a minute. It's kind of that whole, the whole square rectangle kind of thing about, it's kind of the same thing. But basically on this particular rectangular prism, we have 6 faces, because every flat surface is a face. It just so happens that 2 of these faces are what we would call bases. And most people, and I've even seen it in some geometry books, they'll say that a shape will always sit on its base. Well, that's not true. I mean, I could take a triangular pyramid or a rectangular pyramid, we'll go with that one instead of rectangular pyramid. The faces leading up to the vertex at the top, those are triangles because it's a pyramid. But the base is the square, so that's why it's a square-based pyramid or a rectangular pyramid. But I could tip it over and it could sit on one of the triangle faces. But that doesn't make it its base. Its base will always be the square or the rectangle if it's a square-based pyramid. So even if you tip it over, just because I'm sitting on it doesn't mean that that's the base. So that's the same thing with this. What's a little confusing about a rectangular prism is that all sides are always rectangles. It just so happens that for this particular one, it has, for its bases, it has squares, but it's still called a rectangular prism. If I would slice this, if I would go through the diagonal here on my square base, and I'd slice it, I would then have 2 triangular prisms. Well, my faces then on my prisms are always rectangles, but my bases give it its name. And so then if I would slice this, then I would have 2 triangular prisms because my bases are triangles. Okay, so I'm hoping that makes a little bit of sense. And of course, when you have a cube, who knows which one's the base, because they're all the same. But hopefully that kind of gives you a little bit better idea about the difference between base, because a lot of people kind of struggle. I mean, it's kind of just one of those weird little freaky things that happens in geometry. So right. Hopefully that's clear as mud.
So one last note on lesson number 4 there. In the lesson and in the problem set where it's giving them the area of the base. Again, we don't necessarily have to reference the base, but it's giving them the area, and then it's giving them the height. I thought one good note to say would be that if it says it's 4 inches as the height, then I feel free with my students to let them draw the lines to separate each inch. Instead of just trusting that it is 4 inches, they can go ahead and see that for each of the heights. Then again, they're counting the layers like they just were in Lesson 3. So, going on to Lesson 5, and this is a lesson that we were talking about, and it's very intimidating whenever you first look at it, and it has a whole laundry list of materials that you're going to need. But advanced prep of the materials will be obviously essential to making it start out smoothly and efficiently. And there were a couple suggestions in the lesson of maybe using salt or possibly a cheaper option, some fine sand to be filling into the prisms. Also, we were talking about how one option could be to show the equivalency of a cubic centimeter and a milliliter by just doing whole group instruction and making those observations as a class. That could be another way of delivering the same content and maybe not finding all of the sand or gallons of water or whatever you might need. Also, I made a note that after the opening demonstration and making those observations and having that discussion, it's not as intimidating as it might look, because it does go into other word or application problems where students are applying what they just saw, maybe not demonstrating it over and over. So that is a good lesson, and it is one of our standards that students need to relate volume as from packing to volume as filling. So it is a very, very important lesson that will be good for students and give them what they need, and also give a hands-on, a little bit more engaging activity there. So I'm going to skip on to Lesson 7, and that lesson focuses on application problems, and it has a set of steps that you probably are noticing that it's giving you different tasks for how to guide the students through each problem. We talked about how in the 40 minutes that they give you, it's okay to do 2 to 3 problems, or if you have time, but we just don't want to rush, and we want to focus on allowing the students to use their knowledge and the tools and things that they've been practicing to solve the application problems, which will be very difficult. That's the first lesson like that so far in the module. So applying those new concepts that they're exploring in the application problems just takes a little bit extra time, but it will be worth the time, we're believing so. So Lessons 8 and 9, the building the sculpture, we talked about a little bit, and we said it's a very fun couple lessons. It's a fun project. I know in the Lesson 9 where they are looking at other people's sculptures, it is reaching some higher level of thought processes. We had mentioned that it could be, what is the verb we used? Passed on?
Mm-hmm. Yeah, I mean,
depending on what your students need.
Yeah, it's like in your time. I mean, if you're pressed for time, or your students just aren't at that point, we just felt like 8 and 9, it wasn't essential for their understanding about volume. So, or
meeting a specific standard necessarily.
Yeah.
And we talked about how if you should choose to move topics A and B after D and C, then that would turn out to be one of your last lessons of the year, and would be a really fun, engaging activity for kids in that last week or two of school. So after that, we have a mid-module assessment. If you are going through A, B, C, D, there's a mid-module assessment, and as always, make sure you're digging through that before we even get into planning or digging even deep into the lessons. We could have mentioned that earlier maybe, but just making sure that the mid-module assessment, that you're clear on what students will be expected to do, and that sometimes the terminology can sound a little funky to students, but making sure that you know what's coming and you're going to give them the proper terminology in your instruction so that they feel well prepared for that assessment. So next, topic C is the area of rectangular figures with fractional side lengths, where we talked a little bit about the multiplying of fractions will be essential in this topic, and luckily we just had Module 4 a few weeks before that, so it still should be somewhat fresh in their brains. In lessons 11 and 12, I had a couple notes specifically on preparation, and to make sure you have the patty paper, which if you're like me, you had to get on and Google what in the world is patty paper, but hamburger patty paper,
yeah,
more or less.
Yeah.
But make sure to have plenty of that available. And also how it talks about in the lesson the pre-cut rectangles A through E for each lesson, and I'm specifically saying lessons 11 and 12, because if you look at lesson 12, it's talking about they're different sizes now, but there's still the same pre-cut rectangles that different either pairs or groups of students will be needing to be covering with their unit sizes, which are the patty sheets of paper. And just the fact that prepping for all of your rectangles your mystery rectangles that you'll need in 11 and 12, I could see how that would be saving a lot of time if you just go ahead and cut those all in one setting. On these lessons, we talked about how the students, they need to repeatedly be drawing area models once they get into lesson 12 and they've explored those, but drawing the area models, and how that will help simplify the multiplication process, and hopefully students have had practice with that earlier in the year with whole numbers and using their area model, but that simplifies the multiplying mixed number by mixed number for some of the students, and allowing them to apply the concepts that they learned in Module 4 with the multiplying fractions, but just giving them time to dig deeper into that and be seeing it with the unit sizes and applying that to their understanding of area. Lesson 13, I had a note about making sure that rulers are available to all students. They still need a lot of practice with this basic measuring practice. And also there is a part of the lesson that talks about, it's asking the students to estimate, and how estimating to build that number sense will be very important for the students, so that we aren't getting any answers that aren't very reasonable, but having that step of estimating to think, is my answer even going to make sense? Is this area that I just got possible? And then lessons 14 and 15 are again, word problems like I had talked about in, I believe, topic A or B, and allowing the students to talk and reason and to critique their thought processes and other people's thought processes, obviously politely, but thinking deeper about those, and just a time where, again, take 2 or 3, maybe the 4 problems that they give you, and take the whole 40 minutes to dig deep into those and to really analyze them, while, again, practicing using the area model or other representations that they've been previously using. We were just talking about how those days are so important, even though if there's 3 or 4 problems being done, there's a lot of concepts that they're really starting to own if they're talking with each other and discovering those together. So after that, I think we're ready to head on to topic D.
Topic D is the basically is focusing on those 2D shapes and the classification of those 2-dimensional shapes. We were talking about how the vocabulary for this topic is going to be huge. I did want to go ahead and show you guys, there are a couple of things that you may decide that you want to have handy, get for your kids or something. But the one thing that we want to make sure that you guys understand is the whole understanding about the polygon family tree. And if you've been around in the district very long, you probably have seen the polygon family tree. But what's nice is that in this particular set, what we've done, if I can pull them out. What we've done is I can get to that page really quick. We've made it so that you have the shapes already kind of created for you, so you can make them on some sheets of Bristol paper, and the kids can cut them out, and then they have all of the different shapes so that as they're going through this particular hierarchy of shape classification, they can make sure that they will have, because in our shapes that we've created for you guys, that there will always be at least one shape that will be left behind in each one of those categories. The thing that I know some people are can get concerned about is making sure that they have those definitions and have that understanding of the vocabulary. So another one that Lynette went ahead and created, because we had seen, like I told you guys on the progression, I can't remember which page it was, but in the progression, I told you they had that Venn diagram, but they had left out kites. So we kind of sketched one up, and then Lynette did this up on the computer so that you can see how you have your quadrilaterals, and all of these are quadrilaterals, because you remember all four-sided shapes are quadrilaterals. Then you have your kites, you have your trapezoids, and remember from the progression we're using the inclusive definition of a trapezoid, so it's not just one set of parallel lines anymore, it's now just at least one set of parallel lines. So now rectangles are also trapezoids, rhombi are also trapezoids, a square is also a trapezoid. So this kind of shows that now we have all of these shapes that are trapezoids. Then you have your rhombi, you have your parallelograms, but as you can see, it goes all the way down to where you can see that the square just encompasses all of these different names. So I know the kids, I know Baxter, he was talking about how this would probably make a really great activity for the kids, that you would build it as you go. And in fact, in this particular topic section, they have a nice progression of templates that they will end up creating a nice Venn diagram, because each of the Venn shapes is the shape that is most representative of that particular subcategory. So it really is nice. I think it kind of lends itself. But the thing is that you want to really move beyond just classification. You really need to get to that whole analysis of, why is this shape in here? What makes it so special? Why can it be in here? Why can this shape not be in here? And then start really analyzing instead of just classifying those different shapes. Another one you might want to be able to do is, some of you might have the power polygons. A lot of you, especially 4th and 5th grade teachers, you might have these bags of power polygons. They look like the old overhead transparency things, but they really are great. They did it just because it's a little bit lighter than the wooden ones, but it makes it nice because they do have the rectangles and the squares and the rhombi, and then they have them in different sizes, different shapes, so it really makes it nice. The only thing that Baxter and I found out is they do not have kites, and I thought there was something else.
There was kites.
They didn't have kites in here, and something else. Oh, when you're doing the polygon family tree, as you're going through, these are all, a lot of them are parallelograms, but there's not a shape that is just a parallelogram that would stay. Then they all continue on to move something else. So it didn't have anything, that's what it was. It was specifically a parallelogram only. The next thing that they also talk about is measuring angles, which they are doing in 4th grade. And the thing, I probably ought to do maybe you can kind of see a little bit better if I hold this up with white backing. But you can kind of see this is a full circle protractor. This is what's kind of confusing to some kids, to understand that when you're measuring degrees, if you use a half circle protractor, they don't understand. They don't have that understanding that it really is a full circle, because we always talk about a circle is 360 degrees, and then we give them this half half protractor, and sometimes it's kind of confusing. So we do have a template for these. The only thing is hopefully somewhere in your school somebody has kept a set of the old transparencies that you could fit through the copy machine. So if you take the template that we have on the portal, you can put that in, make copies. There's three of these on a sheet. So, you know, make it, if you want to make enough for 30, you know, get 10 sheets. But then the thing is then you want to laminate them twice. You can make them a little bit thicker because the transparency sheets are kind of flimsy. But if you laminate it twice, makes them a little bit thicker, and they cut them out, and the kids can then measure, and they can actually see that it is part of a circle when you're talking about the angles. And we also want to make sure that the kids understand that the angle measure is the sweep of the ray, and it's not
the extension.
Yeah, because that's what they get really confused. Here's a quick example too. A lot of times when I give kids a couple of choices, I'll say which angle is the greater angle. Well, they almost always go for this one because they're looking at the length of the rays, which we try to tell them it doesn't matter. I mean, rays, it doesn't matter how long, how short they are, because of the arrow, it means it goes on forever and ever, ever. But they just see the short stubby rays, and so you're going, oh, okay, well, this one's bigger. Well, so what's nice about the patty paper, which since you have patty paper, hopefully, because you've been using it for your other thing, what's nice is then you can they can layer. They can then draw those two angles and then layer it, and they can see right away. And then you can talk about the sweep. That this one, if you're looking at this horizontal line, this one only sweeps to here. This one sweeps all the way over here, so it's the greater angle. So it makes it really nice to get them to start thinking about what does the angle really mean. The other thing is that, whoops, what did I do with my paper? I used it. I forgot to use it for my back. The other thing is that there's a correction that you guys need to really look at. It was funny because when Baxter and I were kind of looking at the Venn diagram that they had, or they were asking to sort trapezoids from non-trapezoids, then it says, if you look on lesson 15, it's page 5D6, it'll say sort, and it says the trapezoid set includes shapes A, B, D, I think it says J and K. Well, J is incorrect, and they maybe have made this correction already on the new updated one, but we wanted to make sure you guys had the correct one. And they missed some of the shapes that really are trapezoids, but as Baxter was pointing out, he said, well, it just says it includes, that it's not all of them. So I'm like, well, okay, so we're going to give them the benefit of the doubt. I was like, well, good point. So really it is shapes A, B, C, D, G, H, I, K, and L. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of those shapes that are actually trapezoids. And that's using the template from lesson 15 that they're supposed to be doing that sorting. So I wanted to make sure that was something that we kind of caught, and so I wanted to make sure that you guys got that correction. They do talk about one of the vocabulary words is bisect. They talk about that early on. They do a great job of defining that in lesson 17, so don't worry about that. Lesson 19 does a really good job of explaining kites. So as you're going through and building that Venn diagram together. And then it just makes it really nice because by the time they get to the end, they have that nice template so that they can see that how that hierarchy kind of came together, and they have a better understanding about how the shapes work and fit together. So I think that is it. I can't think of anything else that was on that particular one, but I appreciate it. I appreciate Baxter being able to come and kind of be my sidekick while we do this kind of presenting, but I want to make sure because he's in the classroom, has been doing these things, has the kids working on these different topics, so we want to kind of get his input and insight. So please feel free to email us or ask questions about anything in here, and have a wonderful rest of your year. Thanks.